No, you changes every day.
Sir, SIDS is actually the system which is providing the system interaction between the cabins, between the cabin crew. Like if somebody wants to call the cabin crew, being a passenger, so his command will be go to some directors, and that will be transmitted to the decoder encoder units which are there, and then the light will be on. So actually, it is managing the cabin systems.
Okay, good. So this is a cabin interface or cabin system, which is an interface between the passenger to the cabin crew, passenger to the cabin crew to the cockpit crew, as well as some ground services. And we have a lot of interfaces from the aircraft computers, aircraft systems. So they are necessary for the cabin operations. Certain things are for the automatic operations, certain things are for indications like the water waste indications, right? Drain mast, escape slide. So these things, they are cabin functions. They are also is a part of cabin intercommunication system. So if you see by and large, this is the overall components available. It's a classic aircraft. As I told you in the introduction class, there are the two models available. One is a classic, another is an enhanced. When this 320 was designed, it was before 1985. When 320 was designed, it was before 1985. So after 1985, nowadays, if you will see, almost 35 years, 40 years almost, the electronics, software, so many things have changed. But when the enhanced aircraft came close to 2000, at that time also a lot of electronics change, software started coming. So technologically, there is a lot of changes in 15 years, starting from 1985 to close to 2000. So they have modified a lot of component in the EFIS system. They have modified a lot of component in the EIS system, as well as communications, sorry, SID system. That's why we have seen the differences in the EIS also. And so the differences are here as well, right? In the SIDs. So basic structure of the SIDs remains same. Basic structure of the SIDs remains same. The major differences are the consolidation of certain components as well as change of components. Consolidation means multiple component, multiple systems combined together in one computer, right? So they remove the computers and those functions are available with one computer or two computers, right? So just quickly see this. The system is designed around two aircraft, two directors, which you call as a director one and director two, and they manage every functions of cabin. Now, to interact with the passengers, you have a DUA, decoder encoder unit A. They are connected with some top line buses. We'll discuss in detail. There are DUB, decoder encoder unit B. They are mainly for cabin crew functions as well as interface with the aircraft systems. Interface is aircraft systems means panels. They are connected with the escape slide pressures, right? Water, waste, drain mast. So all these things, they are interfaced through the DUB and to the director. Cabin crew interface is a FAP, forward attendant panel, which has multiple sections: air conditioning, cabin lighting, audio, water and waste, and some hard keys are available downside. Function keys are available. So it is mainly for the cabin crew operations. PTP is there, programming and test panel, that is always close behind a panel. So normal case, it is not visible. It is mainly for the maintenance people. Cabin crew will not have an access to this. Only the maintenance people use it to do their maintenance activities through PTP. They can do the same thing from the MCD also. So it's available from both places. As I said, lot of interfaces are there from the cockpit. We'll see in detail over the period of time. As far as cabin crews are concerned, ACP, AIP, AAP, right? Many elements are available. There's a display for the ACP area call panel. Some text messages are coming on the display unit, which is AIP. Additional attendant panel is available, which is mainly the keys are there, keys and lights are there. Then handset is available for the communication purpose. For passengers, there is a passenger service unit available. So all just above the seat, whatever the interfaces you have, which is mainly the noise smoking sign, fasten seat belt, reading light, air conditioning levers, right? Speaker phone, oxygen service unit or oxygen mask. So many things are available overhead. This is a PSU, passenger service unit. It is just above the every seat group. Right, sir. So this is a bit introduction about what we are going to talk about in AIS system. Sorry, set system.
Yeah, yeah.
If you will see in detail, it look like this. Not everything, but most of the things are here. So these are two directors are available, director 1 and director 2. They are connected with the top line buses. Top line bus is nothing but a twisted pair cable. Communication buses are there. Two wires are there, twisted pair cable, right? And this is a decoder encoder unit A, both side. As far as lines are concerned, for redundancy purpose, you have a two lines available, two on the left hand side and two lines on the right hand side. So total 4 communication lines are available. The decoder encoder unit A, they are connected with the two lines, two on the left hand side and two on the right hand side. And the interface arrangement is such that if you just go through it for understanding purpose, on one line, each side alternate numbers are connected. Each side alternate number means 1, the next is 5, the next is 9. So odd numbers are on left hand side, even numbers are on right hand side. You get my point? This is the DU number, decoder encoder unit number 2, 4, 6, 8, 10, 12, like this. This is a FIN number actually, functional identification number. Over and above, over that, the two lines are having an alternate DU. If number 1 is on one line, then number 2 is on another, number 3 on another line. 5 is on one line, so 7 is on other line. 9 is on one line, then 11 is on another line. Correct? Same is other side also. What is the purpose of this interface? That is for redundancy. And if one line breaks, one communication line is unserviceable, the information loss has to be minimum. Information loss has to be minimum. That's why if one line is completely unserviceable, why I'm saying completely, I will explain you. One line is completely unserviceable, so you are losing only 25% seat groups. Are you getting me? You are losing only 25 seat groups. Over and above, see here, they have a very specific kind of arrangement. When we'll go to the DU study, then we'll come to know. If let us say the line is broken at this point, okay? If line is broken at this point, so you are losing only this. They are still working. The connection is made in such a way that all the DU before the break will keep on working. So you are losing only now this much. It's not 25%. 25% will be only when you break the line, at least here, somewhere before this DUA. So then you will lose the full DUAs. You got it? Hello.
Yes.
Yes, sir.
Yes, sir.
Okay. So this is the arrangement of decoder encoder unit A. Now, what a particular decoder encoder unit is performing functions. So you see the functions here. These are the functions of decoder encoder unit alpha. It means it is eliminating the sign light. Sign light is a reading light. Sorry, sign light is a no smoking sign. Fasten seat belt. And nowadays we are using the PED, personal electronic devices. So all these lights are illuminated or controlled by DUA. Then cabin light. We are operating cabin lights. In the cabin general illuminations, two lights are available. If you remember, I told you in light chapter. I took light chapter, right? 33. I shown you the video also. So in the cabin, the general illumination, two lights are available. There are the lights in the window and there are the lights in the ceiling. Correct? The window lights are there and ceiling lights are there. So each DUA, decoder encoder unit alpha, is controlling the four tube lights. Right? It is controlling four tube lights, each DUA. So that light control is also done by decoder encoder unit A. Then you have a loudspeaker for audio purpose. Call buttons are available. They are also controlled. And reading light power unit. Reading light power unit means every passenger has a 111 reading light. So they are also controlled by DUO. It means whatever the functions you are having over the passenger service unit, they all are going to decoder encoder unit, which is located nearby, the seat in the COE panels. Clear, sir? Details we will see subsequently. So decoder encoder unit A. Now numbers I'm not concerned about. In the training material, they say that 26 to 30 DUA are installed above the window and the cabin and close to the center ceiling, DUA in the entrance area. The type DUA are connected to the director by a top line buses, twisted pair cables. Broken wire in one top line will only affect the DUA behind the crack, behind the damage, or after the damage. Before the damage, it will not affect. They all keep on working. DUA or decoder encoder unit alpha of other top line bus will work without any disturbances. Passenger signs we already talked about. No smoking, fasten seat belt, no electronic devices. Right? Cabin lights. There is a various cabin lights are available as applicable. There may be entrance light, there is lavatory light, attendant light, reading light, cabin fluorescent strips. So these lights are also controlled as and when applicable, wherever it is applicable through the respective decoder encoder units. Correct. And now entrance light, it may not be controlled by the middle DU or DU located at the seat number 8 alpha or 7 alpha or 6 alpha. So definitely they have a separate DUA available in the entrance area. So they will control these functions. Right? So it depends where the DUA is located, nearby what functions are required, it will control. Loudspeaker installed in the passenger service unit and each lavatory. They are identical. You can replace them. They are used for the passenger address, call sign, etc. There is a call button available on the each seat along with the seat row number. So call light is along with the seat row number. So when you call, the seat row number also illuminated. It's just a tag identification. As well as they are also in the laboratory. And reading light power supply unit, they are used for the reading light purpose. Right, sir. So this is what we have seen. Some pages are here and there. That's why I have to move forth and back. Now everything will be streamlined. Because they started the DU system from here. This page should not be here. This page should be either before this diagram or after this diagram. So by mistake, when they rearrange the pages, it is changed. Anyway, now everything will be streamlined. DUB, decoder encoder unit Bravo. So DUB They are used for cabin crew functions and the aircraft functions. Decoder encoder unit, Bravo. They are used for the cabin crew functions and aircraft functions. What functions they have? They are connected with the cabin crew handset, attendant indication panel, AIP. Every cabin crew station, they have a display unit available, right? We'll discuss all these elements one by one once we finish the basic architecture. AIP is a nothing but it's a display unit which is located above in front of every cabin crew unit. Sorry, cabin crew station. Wherever the cabin crew are sitting, in front of them there is a display unit for knowing what kind of communication is going on. It is a normal, it is emergency, who is calling, who wants services, etc. etc. We'll see that subsequently. Then you have a EPSU. It is an electrical chapter. We discuss in the electrical chapter also emergency power supply unit. So status of the emergency power supply unit is also available on the FAB, forward attendant panel, or you have on the FAB, if you can see just here, manual control, right? As well as they are also controlled from the MCDU for the battery test, battery capacity test, right? EPSU test. So they need to be interfaced with the director, and they cannot be directly interfaced to the director, so they are interfaced through decoder encoder unit B. Right? Nearby decoder encoder unit B, they are interfaced, and then they'll go to the director. From director, they will go to the computers, STAC, EIS system, MCDU, whatever it is you call it. So this is the system for DUB, right? As far as 320 is concerned, we are talking all these elements in respect of 320 aircraft. So 320 aircraft, we have a provision of 6 decoder encoder unit. I said provision. If you see the diagram, we have a 6 DUB, that is a decoder encoder unit Bravo. 6 provision is there, but in 320 only 4 are installed. 4 are only installed, 2 are left vacant, maybe for the future use. Last 20 years, I have never seen that someone is using the 5th one. There is no other services increase. In fact, they are reducing the services and converting them into the digital communication. So you can expect they will be reduced, they will not be increased. Okay. Because in this diagram, you are seeing the discrete communication. There is no digital communication. Every function is controlled by the single wire. But in the new one, when we discuss in the new SID system, then it is a digital communication is started in the enhanced version. So when the digital communication is there, then you may not have more DUB, rather it will reduce, it will not increase. But that designer will think of how to do, what to do, etc. Anyway, as far as installation is concerned, there is a provision of the 6 decoder encoder unit Bravo, and we are using only 4. 2 are kept optional. Right, sir? 2 are kept optional. So you can see the location. Door number 1R, their location is close to the emergency doors and emergency windows. Their locations are, because these are the cabin crew stations. Cabin crew will not sit here and there. They have designated places close to the doors only. Wherever you have emergency doors or emergency windows, then there is a provision for cabin crew. So 1L, 1R, door number. Middle section, that is emergency sections. 4R, 4L, there is a cabin crew stations. So these DUVs are located in these places. Number 3 and number 2 is a optional. So you will not find, but the wiring is connected there. The mounting plate is available, but the unit is not there. Okay. They are also connected with the drain mast. They are also connected with the area call panel through the decoder encoder unit Bravo. as well as these functions are optional in classic aircraft. The functions are door pressure sensors. They are the pressure switches actually. Door pressure sensor, right hand side and left hand side, both the doors. Slide pressure, left hand side and right hand side, both side. Area call panel additional if you have. If you have additional area call panel in the middle section, then also they are connected with the BUV. Clear? What is the door pressure and slide pressure? Any idea?
Assist bottle pressure.
1800.
1800
800 PSI.
PSI. Yeah. Why we use this?
The
Case of
pressure.
emergency is going to open by itself. You just unlatch it and it should open.
When it is latched and open, right?
Yep.
Normally, do we use this bottle or not?
No.
No, sir.
Oh,
When the handle
no,
is
we
in
do
the
not
arm
use.
position, if you open the door in arm position, then this bottle will be used. Assist bottle.
We just check the range of the in green or in yellow or in and we add the pressure.
Yeah.
It's
Thank you.
yeah. Okay.
Very correct. So first of all, its operation is required when you are operating the door in emergency condition, when the door is armed. It means the slide is armed. Then to assist the cabin crew to open the door due to emergency, this system is used. Otherwise, it will not be used. When they disarm, the bottle pressure is disconnected. So every time when they are on the ground, they open and close the doors, they will not use the bottle, right? Secondly, why the pressure switch is optional here? In earlier design, when they started, it is a headache actually to know the pressure. And I mean, if pressure switch is provided, it is good, but it is an extra element, extra component. So you have to look for maintenance, pricing, and all these things. Or alternately, what Mr. Hitham has said, there is a pressure gauge, you can go and check it, whether the pressure is leaked. If you don't have a pressure switch, you will not come to know whether there is a pressure or that is a leaked out. Are you getting my point?
Yes.
So in the classic aircraft, the option was given what you want to the airline. Accordingly, they will install it. If they install the pressure switch, then the costing will change. Right. But you will have a headache of looking for the pressure every daily check or weekly check, whatever it is. Every flight you will not check for sure. But every daily, weekly, whenever you have a schedule, you will go and open the panel and check the pressure. Correct? So it is an additional element of the check. But if you provide the pressure switch, then you will not check it. Because whenever the pressure is low, you will get the message. So it is a balance between, pricing. So that's why it was kept optional, because you have a 4 doors available, 3 doors, 4 doors, 4 doors, 6 doors, 6 slides are available. So 12 installations is required. Correct? One for the bottle, one for the escape slide. So anyway, this is altogether different. Our purpose is to understand it from the technical point of view. Clear? So this was the arrangement for decoder encoder unit Bravo.
So just a quick question. How does it help for the drain mast?
How does it
Help apart from the when the heater is on?
The drain mast have a control units. Electronic control units are there on the drain mast for the heating control purpose. Right. So you have to ensure whether the control unit is working or not, control unit is failed, or the drain mast heater is failed.
Okay, yes.
So you need to know about it. If let's say any one of them is not working, it means the heating will not be there. And when the heating will not be there, then we have studied in chapter 30. What will happen? The drain mast. So
Yeah, it will be
Ice,
blocked.
ice.
ice
Ice.
formation will be there, right? Ice formation will be there, drain mask will be choked, then cabin crew cannot use the galley, respective galley, cabin and passenger cannot use the toilet. Otherwise, the water will start overflowing and will come to the floor. So cabin
Okay.
crew need to know about it. Otherwise, they'll not know whether it is working or it's not working until unless it is start overflowing. Okay. So this is all we talk about. 4 are installed, 6 is a provision. Near the exit doors, 321, which can be equipped with the DU 8 DUB, because the doors and emergency systems are more. Doors are more in 321. So it can be up to 8 installations. They are connected with the director by the middle line buses. They are not called as a top line buses. They're similar kind of communication, but the nomenclature is different. They are called as a middle line buses. Okay. Slide pressure, as we discussed, it's optional. Door pressure, it is optional. It is a pressure switch only, nothing else. Pressure sensor, pressure switches are there. Cabin crew interphone system, cabin crew handsets are connected. So the cabin crew interphone system is used for communication between the cockpit and cabin, and between cabin crew also, forward and aft cabin crew. Right? Cabin crew communicate to the cabin crew itself, as well as cabin crew communicate to the cockpit. So in both places, communication is there. From each attendant station, it is possible to communicate with personnel at service interphone also. The ground service interphone are also connected with these systems. EPSC are connected to the DUB for emergency lighting system test purpose. So test signal will be sent from the either PTP or from MCDU. Either test signal will be sent either from the PTP, programming and test panel, or from the MCDU. So they will check whether the emergency lighting system is working or not. Drain mast, from the drain mast control unit, if drain mast heater or the control unit fail, then cabin crew will know with the help of its caution light. Right? So they will know that, okay, drain mast is not working. AIP, ACP, additional attendant panel, all these elements we'll talk later on what they are. Directors, as far as director is concerned, we have 2 directors available, director 1 and director 2. 2 directors are there, director 1 and director 2. Their software is controlled by the OBREM. Right? It's not like nowadays they have an inbuilt memory and you can go and put the software in the memory through the laptop or PDL, whatever it is. Earlier days, it was a OBREM only, onboard replaceable module. A SD card kind of memory card was coming. So just download the software, insert into it, and then start the director. That is how they are working. These other interfaces is through the airing 429 buses for the PTP and FAB, right? DUA, DUB, all the DUA, all the DUB are connected through the top line buses, middle line buses, and these are their functions. As far as cockpit is concerned, they have interface from the cockpit for call panel, means call switches are there on the overhead panel, forward crew, aft crew, ground mechanic. Ground mechanic will not come here. So ground, I mean call panel, these other switches are available. Forward crew, etc. Fasten seatbelt, toggle switches are connected. Handset is connected. Service interphone override, service interphone overhead switch is connected. We'll see all these things, right? Am I audible?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay.
You're audible.
As well as other computers are also interfaced. Many more other computers are also there, but for the time being, you can consider aircraft computers are connected and they have a purpose. Flight warning computer for generating the attention getters in case something happen in the cabin. LGCIU, ground flight conditions. Right. SITS is not mentioned here. SITS will be interface. Right. CFDIU is not mentioned here. CFDIU is interface for the by test purpose. SFCC, sled flap control computer is also interface. So we have their specific role. So as we progress, we will know what is the purpose of these computer, other computer interface. Some of them is a common to understand like FWC, LGCIU, CFDIU, SDEC. It's a common purpose. But why SFCC is connected? Why CPC is connected? Right? Why engine interface unit is connected? So we'll discuss all these things once we progress through the class. They are not mentioned here. Correct. So this is all nice to know. These are the functions of SITS director. Only one important thing which you can remember is here the SITS director, only number one is always active. Again, I repeat, like LGCIU or other computer, they change their operations after every cycle. SITS director, no, only the number one is active always. And number two is always hot standby. Number two is always hot standby. You might have heard this word many times, hot standby or standby. What is the difference between hot standby and standby?
So you don't
I
need to
think,
switch it on
yeah,
when
automatic.
it is online automatically. If the number one system is not working well, then two will be online automatically. Or if you switch it on, switch it off, two will be automatically on. This is hot standby.
Okay. Anybody else can little bit polish his statement? He's right.
I think on this, I think on my case, I can just add on what he said. Hot standby is like the way you taught us the DMC goes on automatically for the ECAM on the enhanced. And then on the other classic ones, it's you have to switch, like you have to switch on for the other to get the other DMC. That's what I can say on my case.
Maybe we our understanding is same. Let me put my word what you should understand it. The two computers are there, right? And every computer is continuously getting the information from what is the status in the cabin. Both computers are getting the information from the same time, and they are calculating their status. They are calculating their output also. So both are same level at any moment of time. You got my point? Both the computers are same at any point of time. Only thing is the output is not going from number two. Output is going from the number one. The moment number one fails, immediately at the same position, number two will feed the output. So you don't have to look for that where he stopped and where he started. You got my point? So this is the concept. I mean, through the cross communication, cross talk, or parallel calculations, they are doing it. So that's how the term is used as a hot standby. Standby is sometimes I'm standby when you will tell me I will start working, but you need to know the previous informations, the status of various elements from the inputs from the cabin or from the feeder, whomsoever is, right? So this is my understanding, that they have everything available. They are processing, they are calculating, they are doing everything. Only thing is the output is not going from the standby, hot standby. It will only release the output when number one is failed. Right, sir?
Yes, correct.
Thank you. So we'll talk about the power supply through the diagram. Power supply, they are supplied by the two sources. One is a normal supply, another is an abnormal supply. Normal supply and abnormal supply. Normal supply is they are powered from the service buses and essential bus. Abnormal supply, it will come from the essential bus and hot bus in case required. So normal case need not to discuss because everything is powered by the normal buses. That is service bus. They are supplied from the essential bus and service bus. Correct? Director are continuously energized from the essential and service bus. In normal operation, essential bus bar supplies active director, means number one director. All DUA which is required for PA purpose. Some of the DUA may not be used for the PA purpose, passenger address purpose. So they will not be supplied by essential supply. Correct? So non-essential DUA are not supplied by essential bus. They are supplied by service bus. All DUB which they are connected with the handset or for PA purpose, they are supplied by essential bus in normal case. Right? We'll see through the diagram as well. And other directors, other elements are supplied by essential bus, service bus. Other are supplied by service bus. So in normal case, what we understand, only the few elements are supplied by essential bus. Few elements, active director, DUA, DUB, which they are connected with loudspeaker and handsets for PA purpose. Idea is, if you want to remember in one line, only for the PA purpose. That's it. That is, they are connected with the essential power. Other are connected by the service buses. Okay. So in abnormal conditions, again the same status will be maintained. In abnormal conditions, same status will be maintained, but the service bus is lost, so they will not be powered. Non-essential will not be powered. They lost. You lost them. Second director, non-essential DUA, PTP, FAP, they are not necessary for operation. So they will not be powered. You will save the power. Correct? And PA system will be available. Passenger address system will be available in emergency condition or abnormal condition. We'll see how it is available. Essential bus unavailable. If essential bus power is unavailable, let's say essential is also not available. Essential bus power is unavailable. Circuitry in the director and DUs switches essential circuit to the service bus, and this ensure full seats capability except emergency mode of operations. Let us say aircraft power is available, but you lost the essential bus. Service bus is available, which is a very rare case. Essential will be available, service will not be available. Now think in other way around. Essentially you lost, but service is available. So they can immediately move to the service bus. This ensures essential circuit to the service bus, they will move. This ensures the full seats capability except for emergency mode of operation will not be there. Okay. Main bus is unavailable. If the aircraft loses main buses, means now you lost the service bus and essential bus both. If the main buses are lost, AC bus 1, AC bus 2 lost, so you lost the service buses, you lost the essential buses. Emergency exit lights will be set to the arm position. That is, already the setting is done from the cockpit. Emergency lights are always on arm position. There are the three positions for the emergency light: on, off, and arm. You getting my point? Emergency light has three positions: off, on, and arm. So arm purpose is when there is no power available, immediately the emergency light will be on. So even we lose the main aircraft buses, emergency light will come on automatically, switched automatically to hot battery bus. Right? So let's see the diagram, how it is. And then the byte, service bus failure, passenger address systems, etc., etc. They have their own automatic switching arrangement. So what you see here, this is the normal. This diagram is a normal supply system. Now you see in this case, what is happening? In this case, what's happening? For the supply, you have a service bus, you have essential bus. Are you seeing it, guys?
Yes.
You have service bus available and you have essential bus available. So essential bus is supplying their essential network. These are the circuit breakers. 401 pp, these are the circuit. What is the purpose of this transfer relay? So these are normal. The relay is not energized, and normal condition, this network is supplied. You see whom they are supplying? They are supplying the DUA, which are connected with a speaker, right? They are connected with the speaker. You can see them. They are connected with the speaker, as well as they are also supply DUB. They are connected with the speaker, correct? They are also supply the director, active director. They are also supplying the active director. This is the power supply of the active director. So you can see the active director power supply. This is continuously supplied when this relay is not energized. It means in normal conditions, your DUA, DUB, and director number 1, which are connected with the PA system, are continuously supplied from essential bus. Other components, which is a FAB, PTP, other non-essential DUB, DUA, and director, they are supplied from service bus. I hope this is clear. It means, by and large, everything is powered when the buses are available. Both buses are available. Whomsoever is supplying, essentially is supplying, or service bus supplying, it doesn't make any difference. You have everything powered up. Now, let's go back and see the abnormal situation. This is abnormal situation. Now, in abnormal situation, what happened? You lost the service bus, correct? You lost the service bus. When you lost the service bus, what you lost? You lost the FAB, you lost the PTP, you lost the second director, correct? As well as you will lose, DUA also. The diagram is not shown here, not clear. You will lose DUA also, because you are on essential service. This will only be powered when either the pilot or cabin crew is going to make an announcement. So how this will be powered? At that time, this relay will be energized. And this relay will get the signal from handset, any one of the handset. It means either pilot is pressing his PTT for hot mic. Now, pilot cannot use other systems for PA system. He has to use the black one, handset. That is connected to the SITS director directly. That is directly connected. Other equipment can be used for the radio communication, but this particular handset is directly connected to the SITS director. We will see in the subsequent slide. So when he press the PTT, push to talk on handset, or any cabin crew forward or aft or middle, they are using their communication handset and they press the PTT, right? Then this relay will be energized. So it get the input from so many sources to get energized. And once this get energized, then what happen? it get relay get energized, and then these will be supplied. Then these will be supplied. I think I used the wrong relay, not this relay. This relay is I'm talking about. So then it will be connected with the audio system. The diagram is actually not here. So that's why I got a bit confused. But what explanation I give you, that is correct. Okay. Let me see if something is there in the write-up. Service bus failure. Internal power supply circuit are always checking if the power supply for the service bus is available or not. If the power fail, as long as director 1 is okay, power transfer relay remain energized via the close contact. Director 1 sends signal to energize the top line cutoff relay. With top line cutoff relay energized, emergency mode is active. In emergency mode, power from the essential bus is disconnected to all DUA as long as no PA announcement is there. I hope this is clear. Is it clear, guys? So top line cutoff relay energized, the emergency mode is active. In emergency mode, power from the essential bus bar is disconnected from all the DUA as long as there is a no PA announcement are made. It means they will only be powered when there is a PA announcement. Otherwise, you will waste the energy and you don't have energy available. This relay I was talking about, top line cutoff relay. So complete top line will be cut off. Top line power will be cut off. And that is operated by the audio signal or the PTT switch. Right. Any questions? Hello.
It's okay, sir.
No,
It's
no
okay.
questions for now.
Okay.
I repeatedly say the information is a nice to know, because when you work as an engineer, you will simply do the test and replace the LRU. Right. You won't have that much of time to do the investigation and all these things. Now, let's see the detailed description of decoder, how this DUA is interfaced. So these are all DUA on one side. Top line one side, they all DUAs are connected. Decoder encoder unit alpha, 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 top line bus number 1. Let us say one of the interfaces here. Okay. So these are the two communication wires are coming. This is the complete mounting plate of the DUA, mounting plate. Right. And the DUA is installed on this plate. It has got multiple connectors, J2, J3, J1, many connectors are there. Okay. If you see the connection here, how this communication connection is coming from director. These are the power supply connections, 28-volt DC service and essential. That is controlled through the power control logic, right? Top line cutoff relay logic to the DUA. Now, these communication cables are going in such a way. Can you see here? And from the DUA, it goes to the next DUA. Is that clear, guys? So if that, let's say the line is broken here, it will not affect the operation of this one. It will affect the operation of the subsequent DUAs. That's how the interface is made, the connection is made. Then from J2, they are connected with the lights. 4 lights are connected. You can see both sides, 4 lights are connected. So light have a power supply unit. They may be a window light, they may be ceiling light, they may be a combination, whatever at the nearby location. So accordingly, they are controlling the 4 fluorescent lights in the cabin. Right? As far as PSU is concerned, this is the one PSU, passenger service unit. They are all hardwired. They are all hardwired. You see, the connector is going with the wires. And what they are controlling? These are the 3 reading lights. 3 reading lights are there. This is the call light and call switch. So when you press the switch overhead panel to call the cabin crew, along with the seat number will be illuminated. So there is a lamp. The seat number will be illuminated with the lamp. So you have the call switch and call light. Your loudspeaker is connected. Fasten seat belt, illuminated. No smoking, illuminated. Got it? So these are all input output. They are connected at the PSU, passenger supply service unit. These are the functions we have. Some airline, you may not have a loudspeaker on every seat group. Some airline, you may not have a loudspeaker on every seat group. You may have an alternate seat. Like you are on the seat number 1, 2, 3, left hand side. So it may be on the 1, 3, 5. 2 and 4 may not have. Correct? Or maybe on the 2, 4, 6, 1, 3, 5 may not have. Whatever the arrangement is, you can see them. Clear? Yes, Mr. Anton.
So in this diagram which you showed me on the PSU, when the cabin crew comes in, how do they reset light in the
Press the switch again.
in the same switch?
Yeah, same
Okay,
switch.
okay.
Pressing. You can do that
It's the
same
same
when you are
switch.
traveling next time. When you travel next time, you can press
Okay.
it again, it will reset. Okay.
Okay,
Secondly,
thank you.
secondly, in the enhanced aircraft, now you ask the questions. In the enhanced aircraft, they have a provision from the FAP also. From FAP also, they can reset the particular call.
All right.
But that is only in the enhanced aircraft, not in the classic aircraft.
Okay, sir. Thank you.
You're welcome. So is this clear, guys? So now you see one DUA is able to provide the information to 3 seat group. It means total 9 seats. Maximum. This is a 3 seat group. 1 row, 1 row, 1 row. So 3 rows are there. Correct? And they all are connected to the one DUA. It means one DUA can handle up to 9 seats. So that's why you have a 26. 26 into 9, you can multiply how many seats it can control. So many seats it can control, right? 26 into 9, it goes to be almost 204. It can control up to 204 seats. But the problem is that every DUA will not be connected to the 9 seats. You may be emergency exit, right? You may be in the forward sections where only the entrance lights and all these things are used. In the rear entry also, you will have one where no seats are available. Only the lights are there. So it's a like mix and match. Any question on this?
Okay.
So all these we discussed. Coding switch, I'll come to you little bit late. Top line bus. each side of the passenger cabin connected with a type A DU to the director via termination registers that is used for the impedance matching. Broken top line can affect no more than half of the DUA installed on one cabin side. If the communication broken line is broken, it will not make unserviceable DU more than 25% on each side. Means 50% on each side. 25% overall. Coding switch will come because every DUA is known by a unique address. So how to give the address, we will see that. Power up, when you do the power up, it is able to recognize the 95% failure automatically. That which unit is failed. With the help of power up test, it can recognize and it will tell you that which DUA, which type light, which light is not working, etc. etc. It is able to recognize all the failure. Emergency. In the emergency, all DUB operate in the emergency mode when DC service bus is no longer powered. When the DC bus is not powered, then they will operate in the emergency mode. And DU are supplied from the DC essential bus. Type A DU, that is a P address circuit, and B DUB interphone remains operational in emergency mode. Fail-safe operation in case your, let's say, particular DUA fail, right? Not power supply fail. A particular DUA is failed. What will be the normal operation? What will be the operation in this DU failure conditions? So they will maintain the status for some time. Status for some time, whatever the status they have at that time. Someone has called, some lights are going on, some. So that status will be maintained for some time, and then it will go to the fail-safe mode. And what is the fail-safe mode? All the services will be switched off and light will go to 100%. All the 4 lights will go to 100%. Other services will be switched off. Clear? So then light will not have any control. They will be on throughout. If DUA, particular DUA fails in the operation, they will maintain the status for some time. And after that, it will go to the fail-safe mode and all the fluorescent light will go to the full brightness. So cabin crew cannot control them as a dim 1, dim 2 or bright. No control, full bright always. I hope this is clear. This is these lights 1, 2, 3, 4. If this fails, these light will be 100% on. Other services will not be there. Clear, sir? Let's take a break. Then we will continue.